Hello, everyone. Hello, everyone. That's better. You guys can hear me from back there? Move your head. Is that fine? Okay. I didn't expect to have so many people as the last session of the conference. I mean, you guys are very resilient. All right. So my name is Abder. I'm Luca Bolognese. I work on the languages team, which means I help building C#, Visual Basic, and F#. Today's presentation is about F#, so let's get to it. All right. I'm going to talk for an hour on this slide, so you guys... All right, so my first statement is that writing code is fun. I mean, we don't do it for money, right? We will be doing it anyway. Right? It's true. I mean, that's the truth, right? And it's especially, let's not tell our managers, but that's the truth, right? And it's especially fun in these days. In these days, you're there, you write code, IntelliSense pops up, tells you all the things that you can call. If you screw up something, you know, the IDE is going to tell you immediately. You can set breakpoints. You have an object-oriented language that you can work with. You compile down to IL, and you have a virtual machine that is optimized to run. And you have all this infrastructure, and we kind of, the .NET framework, this huge collection of utilities that are there for you to use. I mean, we have all this stuff. We kind of take it for granted these days, but it's all there. And there is kind of just one aspect of writing code that hasn't changed much in a very long time. And it is the way that you write, that we write our algorithm in the code. I mean, we still talk to the machine in a very imperative fashion. We tell the machine how we want things done. We don't tell the machine what we are trying to achieve. It's like, it's like going to a bar and telling the guy behind the counter, I want a cappuccino, or going to a bar and tell to the same guy, now you grind the coffee, then get the water, warm it. At the same time, prepare the milk. And I want these two things to go in parallel, but at the same, you know what I mean? I came up with this one 5 minutes ago, but it kind of gives you the idea. And that's kind of the way that we talk to the machine. We are there with variable, with for loops, indexing into arrays, and we are doing all of that. And to give you another way of looking at this, when we look at this thing, it makes perfect sense to us. I mean, what's that? We are just incrementing a variable, right? As programmers, that makes perfect sense. But if you take a more declarative view of this, and you look at this as a mathematician, this is an equation that doesn't make any sense, right? I mean, think about it. There is no x for which x is equal to x plus 1, right? But this imperative way of thinking, it's so intrinsic to us that that's the way we do things. And kind of all our programming languages are on that, in that vein, both C#, VB, and there are other programming languages out there, and they are very successful, especially in the scientific community or in the financial community. Things like Lisp or OCaml or Erlang, there are Haskell. There are so many of them. They are fantastic languages. And as I said, they are very successful in those domains, but they haven't really catch on. I mean, to the mainstream, right? It's not something that you talk to the average programmer and they know about or they use every day. And we can speculate of why that is the case, right? You can have your own idea, I can have my own idea, but one reason for certain is that none of those languages has all the tools that I was describing before. I mean, they don't have a professional IDE that you can go and look. They don't have good debuggers. The virtual machine often is not a first-class virtual machine. It doesn't have something like the .NET framework. You know, those are fantastic languages, and in fact, F# has taken a lot from those. You know, a lot of ideas in F# come from those languages. But they never had all the rich environment that the .NET languages give you. So what we are doing with F# is taking all the power that comes from those languages, from those declarative languages, and merge it with all the good things that are there in .NET. So that you can use this style, this kind of declarative style of programming in your day-to-day work. And you've got all the things that you're used for. Now you're probably thinking, I have no idea what this guy is talking about. You know, you see me, I'm making kind of large generalizations, and you're thinking, does that even apply to me? And so I'm going to spend the next hour just writing code and try to use that as a way to see if I can kind of prove my point there. So let's go and write some code here. All right, you guys can, yeah. Is the font big enough for you down there? Yeah, you can see? Do something. Yeah, okay. All right. Typically, the way that an F# program works, the way that you write code in F# is slightly different from how you might be used in C# or VB. So there is usually a script file inside your program, and you use that to kind of to explore your domain, to write code and execute it, as you do with dynamic languages, with IronPython or those languages. And you write some code, you execute it, you write, you execute, until you are confident that you got everything right. Then you compile, and you have your normal cycle. So and this is the script.fsx file. By the way, this is Visual Studio. It doesn't look like Visual Studio because I disable everything, but it is indeed Visual Studio. If you go to Tool Options and uncheck like a crazy man, you can get it to look like this. I think it's, yeah. So this is where you write code on the top, and here is where the code gets executed. So for example, if I write a line of code like let epsilon equal 0, like so, I can then highlight my code, and by hitting Alt and Enter, the code will be executed here. So now I have an epsilon, which is an int, and I can look inside the int, so on and so forth. Light, I wouldn't mind it much. Just put it on top of your files, and life is good. I don't even want to get into that. Let, it's the most important keyword in the F# language. I want you to finish this presentation by remembering just 3 keywords, and let 3 things. And let is the first one. Let doesn't mean assign a value to a variable. What let means is bind a value to a symbol. Those are different things. When you assign a value to a variable, then later on you can change this variable. You can do all sorts of things with this variable. When you bind something to a symbol, it has that value forever, for all the rest of your program. Okay? In all the rest of your program, when you write X, you could have written 0. In fact, your whole program, in theory, if you're doing pure functional stuff, could be written in just 1 line. It wouldn't be understandable, but you could do it in theory. So you can use let to bind the value. You can use let to create a list of things. For example, I create a list of doubles here. 1, 2, 3, 4. And I execute it like so. And now I've got, in F# double are called float for some reason. All right, so now I have my list. I can also define functions with let. I can say let square of x equal x multiplied by x. And I can execute it down here. Then to check that it works, I can do square of 3. And it is indeed 9. All right, so this is let. You can use it to define stuff, to bind things to symbols. Someone is doing this. Oh, yeah, then if I have to do this, then all my magic goes away, because I need to... But it's more important that you guys can see what's going on. So, right? All right. This way? Is this good? Okay. All right. I'm in control again. All right. So what I want to do here, I want to write a function, a simple function, then calculates the sum of squares. I have a list of things, of floats. I want to square each one of them and calculate the sum of them. I will write this function first as you would write it in C#. Let's say in an imperative fashion. And then we will work our way and make it more declarative until we get to how you would write it in F#. So, but first, let's write it as you would do in an imperative language. So let's define a function called sum of squares, imperative that takes a bunch of numbers, and I will say let mutable accumulator equal 0. When I say let mutable, I'm doing something completely different than if I just say let. When I say let mutable, I am indeed assigning a value to a variable. I'm really assigning that value to a location in memory. That's exactly what I'm doing. And I use let mutable here because I'm writing code as I would do in an imperative language. I will never write code like this in F#. I'm just kind of making a point. I go and say for each in nums, for everything that is in num, I will do accumulator. And I will take this accumulator, I will sum the square of my x, and then I will return my accumulator like so. So this is how you would write this function in C#, right? You would have an accumulator for each statement. You will put the square and the accumulator inside the accumulator and return at the end of your for each your accumulator. Notice this symbol. I rather enjoy this symbol. When you are working with a variable, so when you are not working with a symbol, then you don't use the equal operator because you're not binding something to a symbol. You are using this arrow that gives you clearly the idea that you are pushing something inside a location in memory. Okay? It's a really a different operator, and I really enjoy this choice. And something else to notice is if I look at sum of square, it's a function that takes a sequence of int and return an int. But how does the compiler know that? I don't say int anywhere in my code. So the compiler just infers the type of my parameter and of my return values. And the way that it does that is, let's look at an example. So sum of square returns an int, all right? The compiler looks at the accumulator and says, okay, it's returning the ACK variable. The ACK variable is binded to an int. 0 is an int. So the return value for this function must be an int. Okay, it kind of works in reverse. Then nums, I'm doing a for each over nums, so it must be a sequence. Because I can do for each only over sequences. And I'm summing the value of x to the accumulator. Accumulator was an integer, so x must be an integer, so it must be a sequence of integers. You understand how it works? So it works back your code and figure out the types, even if you don't have to say that. This is completely different than a dynamic language that really, it's dynamic. It doesn't have the types, right? So that's the way this works. In fact, if I change this to be a float, now my function takes a sequence of float and returns a float. And even my square here now goes from float to float, while before it was going from int to int. So that's kind of how type inference works. And I can now compile this, and I can run it, sum of squares, imperative, and I have my little list of floats, and the result is 30. So, all right, so this is the way that you would practically write code in F#. You will try something, see that it works, go on and kind of continue. So this is how a programmer will write this code. How would a mathematician write this code? Well, it will probably go and say, all right, I have a sum of square function, sum of squares, let's call it f for functional, and it will do if nums is empty, then the sum of square of an empty sequence is 0. If nums is not empty, then this sequence must have a head, which is the first element of the sequence, and a tail, which is the rest of the sequence. And if that is the case, then what I want to do, I want to square the head. I want to define the function as to be recursive. And I want to call back sum of squares, functional over the tail. All right, and if I run this, it still works, and the result is hopefully rather similar than before. So match, what the match operator does is think of it as a switch on steroids. It's a branching mechanism, meaning that depending on the value on the match clause, it would go one branch or the other, but at the same time is a binding mechanism. In fact, notice that here I'm binding the symbol H to the first element of the list, and the symbol T to the rest of the list, and then I can refer to this symbol on the right side. Here, right? If nums were a tuple of 4 things, I could in the same way decompose it here and then refer to each element on the right side. Okay? So this is a more kind of declarative way of doing things. You see here that if there is something, I do this. If there is something else, I do that. You see there is no mutable state in my function. So, things might, you have the intuition that maybe things may be parallelized, maybe. But if you look at this, it's not that much better than the one above it. I mean, you've got recursion, which is a nasty thing, and you've got about the same amount of code there. So, probably we went one step further, but that's not giving us too much there. So let's think again of what we want to do. We want to square each element, and then we want to sum the square. So you would like to write the code in exactly the way that I just mentioned. And indeed, in F#, you will write this function like this. You will say, let's sum of squares of nums, and given nums, you would first, I will explain what I'm doing in a second. You will first square all the elements, and then you would sum them. So this is how you really want to write this code. The way that you think is, I'm squaring everything, and then sum them. The way that you write it is, I'm squaring everything, and then sum them. This operator, that we call the pipeline operator, is the second most important operator in F#. The first one is let, which is a keyword. The second one is pipeline. So you already know 2/3 of the language now. What that operator does is, if you guys are familiar with LINQ, it works very similarly than LINQ. It takes something, whatever is on the left side, and use it on the right side. And so it takes num. So for example, the sequence.map function takes a function and a list of things. So nums becomes the list of things that come over here. Sequence.map returns a sequence of things. And it happens that sequence.sum takes a sequence of things. So the result of this gets passed here. And I could move on, and pipeline thing as you do in PowerShell or as you do in DOS. So you continue pipeline. You take the result of a function, you use it as the input of the next one. And so you move on like that. And sequence.map, what that means, it just applies this function to each element in my sequence. All right, so that after this point in the code, I have a sequence of squared numbers. And then I pass that sequence of square numbers to my sum function. Is that clear what's going on here? Did I explain with a level of decency? Yeah? All right, so this is how you would really write this code. Let's remove the intermediate step for a second so that we can look at the two functions, one close to the other. So you can, I think, immediately see that this is closer to the way that you think about the problem. It's closer to the way that at least you talk about the problem. Then between your mind and the computer, things start to get very imperative, and variables start to get in, and for each loop start to enter the picture. But in your mind, you don't have for each loop. In your mind, you want to square the thing and sum it. And so you can see that. I want to point out another couple of practical things. I mean, in this function up here, there are many places where you can get things wrong. I mean, you might think that you're going to multiply things. And so in that case, you might end up putting a 1 there instead of a 0. You might use, you might do using a multiplication here because, here you might not assign things to the accumulator, or you might return x. The fact that you are manipulating things at such a low level, so close to the machine, means that there are many places when you can screw up, right? And here, there is no such a thing. Here, the flow of control, it's all been encapsulated away from you. So there is no way to initialize the value wrong, because sum, it knows that the first value has to be 0. So you don't have to tell it the thing. There is no for each loop, so you cannot get your indexes wrong or anything, because you are just saying, do this operation for everything. So that's kind of a practical, and indeed, in my own experience, I'm going to take questions at the end. In my own experience, when you write code in this style, if you get it to compile, that sometimes might not be trivial, things tend to work. I mean, very rarely, you still introduce bugs and everything. It's not like a silver bullet, but you tend to introduce less of them because you are manipulating less things. And there is even a more fundamental advantage of doing this way. Let's assume that we have a version of map that is parallel. Okay, it works with all the cores in your machine, and a version of sum that is parallel as well, right? You want to parallelize this code. Well, the only thing that you have to do is to call pmap and psum. And you can go ahead and you can run the thing, and now the whole thing is running. You cannot see it, and I have no way of proving it. I've been looking for funky lights that pops up when threads gets, but I haven't found anything. But that's not important. What's important is that the structure of your code is exactly identical as before. By raising kind of your level of abstraction, you let the machine optimize things in the best possible way. It's like you let the bartender do the coffee in the way that is best, instead of you going there and telling him each step of the way what to do. if you're curious about this PMAP and PSAM, I can show you what they are. It's very, very simple stuff. So PMAP is just an extension method to the sequence module, and it is using the parallel extension framework. That's how we call it. Yes, parallel extension framework that we just kind of release. It's in CTP form on the web. And it's taking the enumerable, making it parallel, and then invoking a parallel select. You know, that's how it's implemented. And parallel sum, again, is the exactly same thing. It's just 2 lines of code. Kind of no magic there, right? But from the point of view of you, this code is exactly kind of the same as it was before. That's another advantage, apart from introducing less bugs and being kind of more composable and be closer to what you think. You know, a practical thing is that things can change under the cover. And given that you haven't specified much, the system can do things for you. So I know what you are, well, what you are thinking, or I think I know what you are thinking. Some of you at least. Every time I get presented something of this thing, it's always with very simple samples. It's like, yeah, wow, you can square integers. Cool. you know? and always those little toy applications with some kind of pseudo-mathematical thing to them. But can you really write the code that you're writing right now in this fashion? Can you write a real application like this? So in the next 20 minutes, I will try to do just that. Write a real application, not just a little toy here. So let's remove all this stuff. That was good as a conceptual way. Does it work? That makes it clear the difference between kind of imperative way of doing things and I always wonder if people tell me no what I'm going to do. You know? Yeah. All right, so the application that I want to write, it does this. It downloads all the stock prices from this website. This is Yahoo Historical. And it's ironical that I'm looking up Microsoft on the Yahoo website. But focus on the kind of the structure of the data. There is a first field that is the date. Then there are a bunch of prices, 4 of them. Then there is the volume for the stock. And then there is the adjusted price. I want to download that data. I want to create an analyzer that calculates all sorts of return, standard deviation over that data. And I want to start from nothing, from scratch. So first thing I want to do, I want to go down here at the bottom. There is a download to spreadsheet. And I can get the shortcut for that. And what that does, it downloads something that has this shape. It's a CSV file that has a first line that is the header, and then it has comma delimited data that represent all the values for my stock. Okay, so that's the data I'm going to operate on. So let me go back to my code here. Given that I'm going to go on the network, I need system.net, and I'm going to need system.io. And by the way, at the end, I'm going to make this parallel and asynchronous. Just to let you know. Kind of. So I want to define the ticker that I'm downloading. I want to download Microsoft. Then my URL is just copy and paste of what I had before. And I can just change Microsoft to be ticker, so that then I can reuse this piece of code. But again, I am exploring the domain. At this moment in time, I don't care about creating functions, classes. I don't care about any of that. I just want to see how things work, so get my algorithm right before I get to that point. So now I have a URL. I can get a request by saying web request.create and takes my URL. I can get my response by saying request.getResponse. Then from the response, you get the stream. And the stream is my response.getResponse stream. Then you need a reader. And you go and you say new stream reader that takes my stream. And then you read from the reader by doing CSV equal reader dot read to end. All right, so now if I execute this, it will go on the network and download all my big, my big text there. Something to notice here is that this code is identical to how I would write it in C#. In fact, if I put var here and I put semicolon here, this is C#. And if I put dim here and I don't put anything there, this is VB. I make jokes out of this, but this is very important. I mean, this is not one of these functional languages that as soon as you start using them, you need to use the paradigm wherever. If you have a library that is not functional, like the .NET library is not functional at all, then from inside C#, you can use this library exactly as you would use it from one of our normal languages. Okay? So that when you communicate with the words, with the outside world, which is not side effect free as much as people would like you to think, you can write this code. You can write normal object-oriented code in F#. That is an important point. I mean, it's not. It goes back to the point of it's a functional language, but it is usable. And not that the others are usable as well. It just you can use all these big, all these tools if you wish. So now that we have the data, now there are things that indeed make sense to do in a more declarative way, which is the parsing of the data to take out all the prices that I need. So I will go ahead and get the prices by doing CSV. CSV at this point is a big string. So string has this split method that takes an array of characters. That is how you want to split the thing. And I'm getting all the lines. A cool thing about F# is that you can write code in this fashion, inspect the thing, so now it returns a string array, and then you can continue pipelining on. So now I have this. I need to skip the first one because it was the header, if you remember. So I'm skipping the first one. Then I want to, again, now I have all the lines. I want to get all the values inside the line. So I will do a map, and I will do fun. I'm going to tell you what fun is in a second. Line. I didn't even say it on purpose. Yeah. And I split in the line like so. And so if I now look at prices, is a sequence of an array of string where each string is one price. So what is fun? Fun is the third most important thing in F#. Fun is a way to define a function on the spot. It's the equivalent of lambda expression in C# or VB. Okay? It's just a very concise way of doing so. So what I am doing here is for each element in my list of lines, just split it, getting all the values. Okay? And I can continue. I mean, and in fact, I will continue. And I know that some of the values have less than 7 cells because the data that you download this way is dirty, so I just want to get the ones that are exactly 7 cells. So I will do, values, and I will just get the ones that are 7, so sequence.length equal 7. All right? And then I want to take out just 2 things from there. I want to take out the date and the closing value of the stock. So the date, I need to parse it by doing system.datetime.parse, and it is the first value in there. Then I say comma. And I want to return the closing price. And that is in values.6 like this. So if I now look at prices, prices return a sequence of a date, time, and the float. It is a sequence of a tuple, okay? Something that has two elements. And it's just that you don't need to explicitly create the tuple. You can just return your values with a comma, and a tuple is created for you. Now I can go and get the prices like this. And I have my list of prices. I can inspect them by just running this. But that's not the right way to see this thing. I really want them on a grid. So I can say grid of my prices. I can take a look at how much we have lost in the past something. Or I can plot it and take a look at this in a graphical fashion. So the plotting and gridding is just for show. I can show you what they are. The plot and grid, I always like to show everything. The plotting, I am using this library. This is a Flying Frog library. It's actually a very, very good library. And they have, let me show you. If you go to their website, they have now a free edition of it. So you can go and download it. You just have to send email to John, and he's going to send it to you. So that's just a little kind of advertisement there. The grid is even more interesting. The grid is just a form, a grid, adding the grid to the control, and binding it. That's all it does. So I knew I was working with prices, so I've created this little plot and grid so that I can visualize things, right? And that's the kind of thing that you can do when you have this explorative way of writing things, right? You try something, you want to display it, you do, and you move forward. Something important is that, this is real code, right? We are not toying around anymore. That's if you write this in C#, you've got your own for each loop nested, variables and things. We are getting close to a real thing. And still, you still have the same declarative way of doing things. So split the things, keep the first, get the values, filter out. You see, it's exactly the way that when I wrote this code that I thought about it. I need to do this, I need to do that, and that's the same way that I express it. So all of this is some piece of reusable code, right, that I would want to reuse somewhere else. Actually, if I was writing this for real, I would probably have one method for this, one method for that, but let's just create a single method for all of this, a single function, for all of this, and we don't need any kind of extract method feature or anything. Tab is extract method. And you can just say load prices to give a name to your method. Call it takes a ticker. And here you want to return the prices. And here we have our little method. And we can just then import it and plot various things. So we can plot Oracle, for example, and see how these guys are doing. eBay. Now I'm going to plot things forever. Yeah? eBay, I own this stock. Not good. So the main point here, notice that I'm using font 18. So I'm using a huge font. This code, to doing all of this, downloading prices, parsing it, getting everything, stays in half of your screen if you use a normal font like 10, right? And I have written all of it using 3 keywords: let, pipeline, and fun. And those three keywords are all you need for 90% of your code. I mean, you really do write almost everything with those three guys. All right, so now I have my little load price method here. I could go ahead, if I don't do anything, I could just compile this and expose it to my C# VB customer, and they will just see a static method that they can call. You know, I don't need to do anything there. But let's say that I want to expose a nicer API. I want to create a stock analyzer class that then you know, has methods and properties to do things. Can I do it inside F#? And indeed, you can, and I'm going to do it now. Let me create a stock analyzer. And let's have it take prices, like so, and the number of days to analyze. The first thing, you remember the prices as both a date and the closing price, but for this application, I just need the closing price. So as I write my code as I always do. I say let prices equal L prices, then pipeline this to sequence.map. And as I said, this thing has a date and the price, but I want to return just the price, so I return just P. Okay? So if I look at this now, it's just a sequence of A. At this point, this is something else of F#. If the compiler doesn't have enough information to figure out the type of something, as in this case, it just assumes it's a generic thing. So you get all the beauty of generic function without you having to say what is generic and what is not. It's just if the compiler can do that for everything, that is a generic parameter. You know what I mean? But you don't need to do any T of T1, T2, T3. It's just the compiler figure it out. You know? And so now, in reality, I'm not using D on the right side, so I could not specify it like so. Or there is already a function that returns the second element of a tuple, and I could just use that one. So that's what I write. And then I just want a number of days. I don't want all the things. I just want days of it. So I do take and I chop my sequence just for this number of days. All right. So now I have my private field, if you wish, prices. Now I want to create a factory method that you pass it a bunch of tickers, and it returns you a bunch of those stock analyzers. So let's call this guy static method get analyzers, and it takes tickers like so and days. And what it does, the code looks very much the same. It does tickers sequence.map. For each ticker, I want to load the prices, like so. And now that I have the prices, I can just return a bunch of stock analyzers. New stock analyzer that takes prices and days, like so. There is something unconvincing about this. Static member, I'm sorry. All right, sorry. I must be rather drunk. Okay, so this is how I get my stock analyzer. Again, look at my code. Pipeline, 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 pipeline. I mean, you can go quite far by doing things this way. All right, so now I have a stock analyzer. I have a way to get stock analyzers given some tickers. Let's introduce two properties in this class. One is the return. And the return will be last price, where last price is equal to prices, and I want the first one, sequence.nth. I will get the first one in the thing, and then start price is prices in the position, the position sequence.nth of days minus 1. And then the return for the stock is simply last price divided by start price minus 1. Member, I should say s.return, sorry. All right, so now I've got my member. It's a property I can call on the thing. Now let's say that I want to calculate the standard deviation. So let's do it. Standard deviation. I'm trying to write a real thing. I mean, that is my goal. All right, so the standard deviation is slightly nasty. The way, if you look up the formula in some places, you need the logarithm of the daily return for each stock. So the way that you do that, one way of doing it at least, is by following our usual way. You say prices. Then there is an operator called pairwise. What this does, if you take a sequence of things, it takes the first one and the second one, and it creates a tuple of those two, then the second one and the third one, and create another tuple, so that in the end you have another sequence that has all the possible pairs. You know, first with second, second with third, third with fourth. It's clear what it does? I didn't even know this thing existed. But it's they're convenient. So now that I have that, I can just take the pair here, do the logarithm of x divided by epsilon, which is the daily return. You know, and this is those are my log. This is the log of the daily price. Then if I have that, then the mean of the log will be log rats. And I will calculate the mean by doing sequence.average. The variance is log rats, again pipelined to sequence.average by, and the function to average on will be the return, and it will be the square of the return minus the mean. I mean, it's not really important what, you know, that the formula is correct. It's the concept that is important. Notice that here I don't have a square because I deleted it from my file, but that is no problem. A function is like, it's a symbol like everything else. I can just define it here. Say that is my square of x equal x multiplied by x. So now I have my square. And I want to return the root, the square root of the variance, and that is the standard deviation. So let me check that I didn't make any error here. No, everything works. So notice what I did. This is just a class. It's a normal class, and again, this is the other half of a page if I was using a normal font. So think about what we have done. We have written all this stuff and everything, and it's all in one page, and all using very few keywords here. So all right, so now I have this thing. I can actually use it from, for example. Well, no, before I use it, I need to make it real. So I told you that I was just experimenting with my domain, right? I was executing, graphing, doing grids and everything. Now I'm happy with my result. I think this is a good class I want to expose. So I just take it, copy. I press the wrong button. I press the right one. I can go to my main F# file, just paste it there, and build. So now I got myself a math library, a component that I can go and use from whenever client I want. In fact, I'm going to use it from C#. And what I'm going to do here, I'm going to create, it's not easy to write in all those languages. Let me tell you that. All right. So I'm going to create myself a list of tickers. Oracle, and let's get eBay here, like so. And then let's get the stock analyzer for those guys. Analyzers equal math library dot. If I now do dot, you see in IntelliSense there is a load prices here. Because by default we expose everything as static method. So, but I don't want to expose that. I just want to expose my stock analyzer. So let me go back to my code here. Look at my load prices method. And this is kind of the beauty of being integrated with .NET. F# has all the same security mechanism, hiding mechanism that all the other .NET languages. In fact, here I will say that this is internal. And then go and build. And now let me go back to my program. And when I say .now, you don't see load prices anymore. I mean, you are working in a mainly functional way, but still you have all the same .NET capabilities. That's what I was kind of trying to show. So you can say stock analyzer dot get analyzers. You pass your tickers, and let's get 365 days here. And then let's for each over this guy. Var analyzer in analyzers. And let's print out the result. Let's say that the return 0. And the standard deviation, well, okay, the standard deviation is 1, like this. And then the first, now you can see the property that I defined in my F# class, a.return. Actually, at this point, it's not even an F# class. It's just a .NET class. There is no way to know that it came from F# or, well, there is no easy way to know. And get the standard deviation. And so I use it in exactly the same way as I would use any other component. And I can go and build this thing, and then I want to run it because I want to show a problem with this stuff. Let me open my little task manager here. Let's sort by image name, and let's run this. Oh. Where do I put that thing? All right, see that now I've started my application and it starts with 10 threads there. And see how it sequentially prints out the return and the standard deviation on the screen. And you look at this and you think to yourself, well, that's rather stupid, right? Why am I waiting to have downloaded the first ticker to download the second one? And then I'm waiting, and then I load the third one. What I really want to do, I want to do those 3 operations on different threads, and not just that. I also want not to keep those threads occupied for all the time of my computation. And the reason for that is that if you look at the way that my function is written here, yes, in this point in the code, I'm just keeping the thread, but I'm not doing anything. I'm waiting for the website to send me a response. So I'm just blocked on nothing, right? And on this point as well, I'm just waiting for the website to send me all the data. And there is no reason for me to keep the thread. And indeed, if I parallelize this, but if I still block on those threads, I could parallelize just to a certain extent. Then the number of threads will be too big, right? So I want not just to parallelize them, but to make them asynchronous. So that when they get to those points in the code, they release the thread to the thread pool, and the thread pool goes, and the web request comes, and when the web request comes back, at that point, a new thread is given to me, and I start executing on this new thread. all right, so that someone else can use my thread while I don't need it. Is that clear what I'm saying? So that's kind of asynchronous programming. If I were writing this in VB or C#, I will look at this function and I will say, all right, I need to take this, create a delegate, pass this delegate to another function. Then I need to take this, create a delegate, the previous delegate, take this as another delegate, and all the flow of my code will be, again, I will be telling the barman how to make my cappuccino. I will be, the flow of control would completely overwhelm whatever logical thing I was trying to do. The infrastructure will be too much. And that's why what we have done in F#, if you want to make this code asynchronous and parallel, you come here and you say async. You go down there and you close your little braces there. Then you have to say return here. And then you go to your code and look at all the places where indeed you want to release control. And one of them is here. And when you want to release control, you just say bang. and you call the asynchronous version of your method. Say bang here, and you call the asynchronous version here. So this is all I need to do. Now, so I mean, granted, it's not like magic. It's not like you don't have to do anything. You still need to tell the system where you want to release the thread. But you are marking it. You are not creating a delegate that takes the other, bring it in. See the difference, right? So now this function is asynchronous. When it gets to this point in the code, it would release the thread. And then when the request comes back, a new thread will be created, and I will start re-executing from this. All right? So now, obviously, this function has to change, because I want this to be executed in parallel, and there is nothing that says here to do it in parallel. Notice how now my load prices returns, it doesn't return a sequence of date, time, and float as before, but it returns an async. And this async is like a token that you can bring along, and you can kind of compose with other async until you are ready to execute. Okay, so you might have parts of your system that creates those async because they know that this thing has to be asynchronous. And they create it until you get to a certain point when you know what you're doing, and then you bring them together and you execute all of them in parallel. But the way that you write your code doesn't change. And so here, I'm doing that merge, of those asyncs. So I'm here. Where I am? I'm here. So at this point, if I look at the type of this, well, it returns a sequence of asyncs, because I'm executing load prices on each element in my list of tickers. So given a sequence of asyncs, I want to take all these async and create an async that is executed in parallel, that executes all of them in parallel. So I just go and I say sequence, no, I say async dot parallel. So now what I get myself, it's an async that returns a sequence of these things. So now I can simply execute it by say async.run, async.run, and now this is exactly as before. So given my previous code, all that I had to do were go, mark the places where I want to be asynchronous, and build and put together those async. So I've changed 4 points in an application. If you had to do this to make this code parallel and asynchronous in any other language, it would be rather more difficult. So now I can build my solution here. I can go back to my little console and run this thing again. again, here I would love to have some flashy lights and everything, but instead, I'm just going to show you that now a driver creates 15 threads instead of 10. And those other threads are, and the thing is much faster, because it's executing also the retrieval in parallel. So it is really happening. It's not PowerPoint or anything. All right, so let me go back here, because you guys are probably curious of what are we doing with F#. Is that a real product? What is it? So before we get to that, so did my demo resonate with you? I mean, you guys now have an idea that F# is declarative, it's easily parallelizable, but at the same time it plays well with all the rest of the .NET framework. And did I prove my point that you can build real things with it? Yeah. Okay, so that's good. Then I don't need to talk through this slide. All right, so F# originally was something coming from Don Syme. Don Syme is the mind behind this thing. And it was in a research, well, there are many people, but Don Syme is the chief architect of this. And it was a research CTP. And so what we did, we took it in the product team, and we are productizing it, which means that we just shipped a September CTP, which is the one that I was using, and it is incredibly stable, and it has a commercial license, so in essence, you can use it and make money, and we don't get any share of it. I think it means that. That's probably an oversimplification of the... I suggest you read the license, but... yeah. But I'm pretty sure that's the concept there. But the most important thing is that in the next year, we are making it a real product, exactly the same as C# or VB.NET. It will be at the same exact level, a first-class language that these two things. So that's what we are doing with it. Yeah, many ways to learn about it. The middle book, Expert F# is written by Don Syme, and all of the three of them are all very good books. The one in the middle, I suggest, even if you don't plan of using F#, just get it and read it, and it just makes you a better programmer, independently if you're using F# or not. So I think I am done here. Thank you guys very much. And I'm opening up for questions. I think there are microphones. You need to go too. And please fill the evaluation form so that we can do better next time around.
Sorry, can I ask?
Who is talking?
Me.
Oh, hello.
You didn't spoke about algebraic data types. Are they supported? And will we see them also in other .NET languages?
Which data types, I'm sorry?
Algebraic data types.
The what?
Union types.
Algebraic, yes. Union types and such. So union types are interesting. To be honest with you, in the upcoming release of .NET, they won't be there. So we are not making them part of .NET. What we are working on is to making tuples part of .NET.
Yeah.
Which is not what you asked.
Are they part of F#? Are they part of F#?
F#? Yes, we have both unions and tuples. Yeah.
In fact, what you are doing with F# is a kind of compressing the meaning of a program. And I think it could be very useful, for example, for rules in Workflow Foundation or something like that.
Absolutely. I mean, when I use F# now, it gives me the impression that I get immediately to the core of my problem. While before I was kind of, dancing around, creating structure and other things. With F# I immediately get the core of what I'm doing in a very succinct form, as you correctly said.
You get condensed meaning of a program.
Yes.
Without specifying the full complications around that.
Yes, the way that we like to express it is to say that we have a very high signal-to-noise ratio. I mean, what you read, it's all signal. There is no noise.
And that's why it makes it some kind of difficult to write it correctly down.
Yes, the first time that you look at it, it's a syntax. Every time you learn a foreign language, or every time you learn a foreign programming language, the first time you look at the page, it looks like someone throws symbol at the page. But you know, that happens everywhere. If you are an OCaml programmer and you are used to F# and you go to C#, you have the similar experience.
In fact, if you are not a programmer, you are thinking exactly like F#.
You are very, very right.
Going to be a programmer, you are swifting out of that.
Yes, it's very interesting. We have some guys that are doing an internship in research, and they haven't written a single line of code. They are just mathematicians. And they look at this thing and they just write code like this. It's just very simple for them to learn, while a programmer sometimes makes, yeah.
It could seem like a maze.
Yeah.
Which a line of code.
I have a question there? Yes?
So in your example up there, web request is a good example of an API that has side effects and everything.
Absolutely.
How exactly do you deal with that? Do you do automatic disposal or something under the hood?
You deal with that in exactly the same way as you do with all the other .NET languages. I mean, I haven't showed it here, but when you say let, you can say instead use. And if you do that, it's like having a using in C#, where when you get to the end of your block, the thing gets disposed for you. So it's exactly the same paradigm. F# is not a pure functional language like Haskell is, where you have to identify the places in your code where you have side effects and treat them differently. You can write whatever sort of code in F# and both side effect free and with side effect, and that is by design. It's a feature of the language. We want to make it practical and usable from, to call it all those places that they are not side effect free, like the real world. So yeah. Yep.
So let's say I'm a C++ programmer who has to deal with a large sequence of data, several megabytes, say. And what I would typically do, and why I would use an accumulator, would be to make sure that I get the result using just a little bit more extra memory, so as to not swell the temporary memory space. So that fancy pipe stuff, how does that, I mean...
if you're thinking at that level, you should be using C++. I mean, that's the language.
Okay.
For you, I mean, when you go to .NET, first of all, you don't get your own memory. The virtual machine goes and does whatever it wants. It might create 100 objects and cache them for you, and the little thing that you might gain in your accumulator, it's completely lost in the sea of the things that happen behind the scenes, if you wish. In the particular case that I showed, it's actually not that inefficient, because the fact that you're using sequence means that under the cover you're using IEnumerables, and IEnumerables are lazily populated, so your request goes through. Now, I don't know if you might end up using, a few more bytes that you would do in C++, but you don't have control over that on .NET anyway. So
yeah. that would typically limit the depth of your pipeline.
No, it won't, no? Because if you're using sequence, you're using IEnumerable, and then it is lazily generated. So your pipeline can have, 1,000 of things, but there will be just one go through, and we'll get the first one, then the second one, then the third one. It wouldn't iterate over each one of them.
Okay. And is that model of execution also part of the F# spec? That if I have so many items,
yes.
Okay.
Yes.
Cool, thanks.
Who is, there is a question there? Yeah.
How do you handle exceptions? I mean,
Very similar way as you do in .NET. You have try and catch.
even within
Yeah, they have a
between
different
sequences?
syntax, but it's essentially the same stuff.
Okay.
I like that language feature where you can say these are meters, these are seconds, these are meters
Oh,
per
that's
second.
a fantastic feature.
But
Yeah.
from what I saw in the spec, it's only floats. Are you planning on extending that to other numeric types?
I don't think it's only floats. It is only float, Chris? You know, it's
Floats, doubles, or decimals.
yeah.
What about big int, big number?
Yeah, so it just works on those three. The problem with it is for, say, integers, right? As soon as you express a very complex things like meters per second raised to the second power times floats, right? Like integers with all the conversions and maximum size overflow issues, right? It doesn't make a lot of sense.
But what about big int and big number?
Big int, big num, that's something we can certainly look into.
Yeah. It's a fantastic feature. Unfortunately, I cannot show everything in the
Yeah,
thing. but
because having it for big int and big number
I can
would
tell
be
you,
useful for
in
certain
my code,
domains.
in my code that I have that does this comes from a piece of my code. I had this code like a normal code base. I went through and I put a unit of measure. I discovered 2 bugs in it that I wasn't aware of just by having unit of measure on my floats. I was doing a division of something wrong and I wouldn't realize it, but with unit of measure it comes out that the measure is not the one that you expect, and so it's amazing. And everyone had a similar experience as myself. So
It definitely would help us in terms of having our code audited and for compliance. 'Cause-
The way that I like to describe this feature is a type system for floats.
Yeah. Thanks.
And the first language that I know of that has such a thing. Yeah.
Would it make sense to make unmanaged F++?
To do what?
To make unmanaged F++?
That's an hard one, man. That's an hard one. I think we already have enough languages. Yeah.
Do you have some plan to open source some of F# so that we can use on other
Yeah,
platforms?
we are working on the details, but the whole F#, the roots of F# are in the research community. And in the research community, everything is open source. And right now, if you go and you download it, it's all open source. And we most certainly want to continue doing that. We haven't defined the exact details and the lawyers and everything, but most certainly it will be. Yeah.
I can see the productivity benefits and sort of a simplistic declarative language like this. But are there classifications of programming challenges or problems where this type of language actually is better than a procedural language? And I know ultimately under the covers it's probably all written under, in a very procedural language. So are there classifications of problems where this is actually going to help us solve?
These kind of languages have been very popular in the scientific community when you are manipulating large amounts of data and you are doing, some hard computation over this amount of data in the financial community. And those are the places where it is proven, if you wish, that this kind of writing code, it's more productive. To be completely honest with you, when you start thinking of your problem in this way, they apply this kind of writing code applies rather generally. I mean, you end up writing most of your code in this fashion. And sometimes there are cases where it doesn't make sense, like the places where I showed you the web request and response and everything. There you are working with an object-oriented library, and it just makes sense to write that object-oriented code like that. But when you're doing some algorithmic stuff, you are manipulating the data, you're filtering, you're taking it, you're modifying it, sending it out. All these things are very well suited for this kind of.
It's mostly just for productivity, right? I mean,
it's not just. I mean, the way that I see it, there are a couple of things. One is productivity. Another, I tell you my personal opinion writing code. It's you introduce much less bugs because you say less things, and so you have less things to get wrong. Sure. And you introduce, and it's much easier to parallelize the thing. I mean, sometimes, like I did, you write your code, and then you say, oh, yeah, you know, I need to parallelize this. The fact that you don't have any mutable state in your things, all right, then if I can write this function, this in this thread, this in this thread, and it's rather simple. And it has a number of benefits, and productivity is one of them, but I think there are others.
Thank you.
Can you just give us a couple non-trivial examples of work, of problems you've used, problems that you've used this tool to solve?
Yeah, so there is a very big financial institution, Credit Suisse. They are starting 200 projects in F#, and they've already very many of their quants program are now written in F#. There is the advertisement group in Microsoft, the ones that they do the placement of advertisement on the search page. The whole engine is written in F#. There are a plethora of example and programming of people using this thing. It does work rather nicely. In my personal thing, I've written stock stuff. I'm written Bayesian statistics analysis things. I've written all the financial function in Excel. I've written all the 53 of them, or 56, whatever they are, in F#, which is kind of a huge project. That's my personal thing, but there are entire group of programmers that are using it on a daily basis. There are already, strangely enough, we haven't shipped it yet, but there are already opening jobs for F# on the net, for F# programmers. Okay. I mean, it is real. It's a real language. It's like a C#, VB, you write, yeah. Oh, sorry, I should supposed to do that.
So I'm wondering how far we can push this. There's another class of language that expert systems, whatever you want to call it, rule chaining, the Prolog.
Oh, yeah.
How close does this get to that?
So
good fit, bad fit?
I can tell you that F# is a fantastic language to create little DSLs inside your program. So I can very well see people writing some Prolog-like rules and kind of change the syntax a bit and creating a little DSL that looks very much like Prolog. And so F# is good in creating these things. I don't know if we are going to push the language in the direction that you are suggesting. If we are, doing those
out of the box.
Yeah, out of the box. Most certainly, it's among the languages that we have, the one that is most well suited to create those things. Yeah. Doing it, that's a different matter. Yep.
Yeah, that was an excellent talk.
Thank you, sir.
Is there a reason you preferred the pipeline symbol than nested function calls? I was expecting you to say, function calls, function calls, function.
Oh, that becomes unreadable if you do the nested
okay.
function call. If you do the pipelining, it's the way that the code gets structured is exactly the way that you think about it. Do this, do that, do this. If you do the nested function call, then you got to go to the inside, and that's the first thing that you do. Then you come out and you do the other one. Then you come out.
Right, but it's the purest view of functional programming as function calls. But I didn't know if the pipeline seemed more efficient because of the
pipeline is a part of pure functional thing as well. It's just currying. Okay. It's just curried functions, and it gets.
I'd never seen it presented that way. That was okay.
Yeah, but pipeline is just the syntactic sugar of currying the function. And getting things. So
excellent, thanks.
So yeah. All right. Thanks again.